Hello everyone, this is DSA Zindabad. Today we are going to solve the 16th question of our Goyal DSA sheet, and the question is sub-array sum equals k. Now let's look at the problem statement. Given an array of integer nums and an integer k, you need to return the total number of sub-arrays whose sum equals to k. A sub-array is a contiguous non-empty sequence of elements within an array, right? So first of all, let's discuss the problem statement. What is the goal? We need to find sub-arrays whose sum will be equal to the k value, which is our target, right? This is our goal. So now let's look at the example. Like this one is the example, right? 1, 1, 1, and the target over there is 2. So we need to find the sub arrays from the given array so that this sum will be equal to 2. So from there we can take this sub array, or either we can take this sub array, this and this element, right? 1 and 1, right? So ultimately we have 1 and 2, total number, two number of subarrays whose sum will be equal to k, right? And now let's look at the second example also. Uh, Over there we have 1, 2, 3, and the target equal to 3. From there we can either go for this array or either go for this array. So we have total number of arrays from there equal to 2, which is our answer, right? So we need to return the total number of sub-arrays whose sum equals to the k value, right? I hope problem statement is clear to all of you guys. Now let's jump into the approach and try to figure out how we can solve this question. Approach, right? So whenever we have an array, right, what comes in our, like, just traverse over the array following some condition, right? This is the first thing. Like this comes under brute force approach. Brute force approach, right? Let's say we have this array which is 1, 2, 3, right? And the target value equal to k equal to 3. So we need to traverse over the array such that we find those sub arrays whose sum will be equal to k. So let's say we are at this element. For this element, we need to calculate first sub array can be this, second sub array can be this, third sub array can be this. So for the element number 1, we have 3 possible combinations. So similarly, for this element, we have first this array, and the second array is this. So we have 2 sub arrays for the element 2, and for the third element, we have only 1, right? So what we need to do, we need to generate all possible number of sub arrays, all possible number of sub arrays, and try to calculate their sum and find out if some equal k, which is our target value, then we need to increase our count, right? This is the simple approach. Like just traverse over there. You don't need to worry about like how many loops you are going to use for this approach, right? Because this one is the brute force approach, right? So this will be the pseudocode for the same. Let me just paste this thing. Yeah, over there, as you can see, like we'll directly run 2 loops, right? From ranging from 0 till n, right? So that like we can find out the current sum of the required array. So this one is this will require big of n cross n, which will be ultimately equal to big of n square, right? And the when you talk about the space complexity, it will be big of 1, since we do not require any extra space over there. No extra space over there. No extra space, right? So now let's reduce the time complexity to big O of n for this problem. Let's talk about the optimized approach, right? Optimized approach. So when we talk about the optimized approach, like we need to reduce our time complexity to big O of n, right? So for this, we need to traverse over the array only once. So for this, we'll be using another data structure, which is hash map. So that while traversing the array, we are storing each and every element over there in our hash map by following some condition. Like we need to figure out what will be our key and what will be the value corresponding to the key, right? So in this, we'll follow prefix sum approach. Prefix sum approach, right? I'll also tell the link in the description for you guys to understand like what prefix sum exactly is in the article below. So you can refer this article, which is given in the description below, right? For understanding prefix sum in much better way, right? I'll try to explain prefix sum in this question, like how we are going to use the prefix sum analogy over there in our question, right? So now let's try to take a different example, because like in the problem statement we have like this example 111, and we need to find out k equal to 2, right? So this will be a like this is very small example, so we'll take a much larger example so that this thing is clear to all of you guys. Like we'll take a large array, right? So the array will look something like this. So this will be our array: 3, 9, -2, 4, 1, -7, 2, 6, -5, 8, -3, -7. After -7, we'll have 6, and then 2, then 1, right? This is our num set. And for this, the target value will be equal to 5. There is 5 out there, right? So what we'll be doing, like we'll use hash map key value pair, right? So we'll try to calculate the prefix sum for each and every element, right? Let's say, I'll just give you an example. Let's say we have k equal to 5 over there, right? Let's say we find out that its sum is equal to like you can say x plus k, right? And its sum is equal to x. So ultimately, this array will be our k value, right? So this is the thing which we are going to use in our problem. Like whenever we calculate like from this point to this point, we have this sum x which is equal to x plus k. So and from this point to this point, we have x. So ultimately, from this point to this point, we have a sub array whose sum will be equal to k, and this is our required answer, right? So we'll directly store this sub array in our answer, or directly we can increase the count by 1, right? So now let's discuss how we are going to implement this in a problem, right? As I mentioned previously, like we are going to use hash map, right? So our hash map will store prefix sum. Our hash map will store prefix sum, prefix sum, and the frequency as the value, right? This will be key, and this will be our value, right? Now let's do a diagram, and so that you guys have a better understanding of what I'm trying to say, right? So and this will be initially our prefix sum will be 0, and its frequency will be equal to 1, right? This thing will be clear to all of you guys. Like in the end, I'll just give you an example why we are storing prefix sum initially to be 0 and its frequency to be 1, right? So let's assume now, let's initially we have prefix sum equal to 0 and its frequency equal to 1, right? Now after this, we'll try to calculate the prefix sum for this. 3 plus 0 will be equal to 3. Now we'll check if we have prefix sum, prefix sum minus k present in our map or not, in our map or not. If this element is present, if present, then we are going to uh, take this frequency in our answer, right? So after we calculate 3 minus 5 equal to -2, since -2 is not there in our hash map, so we'll directly increment its frequency 1. So let's say initially we have our answer equal to 0, right? Because we didn't find any sub-array till yet. After this, 3 plus 9 will be equal to 12. Since 12 minus 5 will be equal to 7, 7 is not there in our hash map. It will be ones. Our answer will remain 0, right? After this, 12 minus 2 will be equal to 10. Its frequency will also be 1. 10 minus 5 equal to 5. This element is also not present in our hash map. So we'll increment our pointer to 4. 10 plus 4 will be 14. Its frequency will also be 1. 14 minus 5 equal 9. 9 is not there in our hash map. So we'll increment our pointer. So 14 plus 1 equals 15. 15 minus 5 equal to 10. As we can see, 10 is already there in our hash map, right? So we find out like this condition holds true, and we find out that 15 minus 5 equal 10, and 10 is already there in our hash map, right? So we'll increase our answer by 1 because its frequency is over there 1. So why we are incrementing our answer by 1? Why? Like just try to consider this case, like after this, just till this, from the initial position to this position, we have our sum to be 10, right? From the starting, like our sum, let's say from starting this till we have our sum equal to 10, right? And from there to till there, right? We have our sum to be 15, right? This is the same thing, like as I mentioned previously, like let me just do this thing for you. Let's say this will be our sum equal to x, and from there till there we have our sum equal to x plus q. So it is quite obvious that in between these elements our sum will be equal to k. As you can directly like try to sum this element, 4 plus 1 will be equal to 5, and this will be equal to our k value, right? I hope this makes sense now, like why we are getting like prefix sum and try to minus it over there and try to find out whether this element is present in our hash map or not. If this element is already there in our hash map, then we'll increase our frequency by the frequency of that element which is present in their hash map, right? So its frequency is 1, so we'll directly put minus 1 in our answer. So our first subarray is this, which is 4 comma 1, right? This is our first survey. So now, like moving on further, let me just erase this thing. So this is our first array, subarray, right? So moving on to further, it's 1, right? 15 minus 7 will be equal to 8, and 8 minus 5 will be equal to 3, right? As you can see, 3 is already there in our hash map, right? So we'll again check like until we'll again try to calculate the sum, like its frequency is also 1, so we'll directly increment add this thing to our answer. So 1 plus 1 will be equal to 2, so our answer will now carry two number of sub arrays whose count will be equal to 5. How is it possible? Like till now this will be equal to our sum 3. Now this will be x, right? And from this to this we have our sum x plus k. So it is quite obvious, like in between this will have k equal to 5. So just try to calculate this sum. 9 minus 2 will be equal to 7. 7 plus 5 will be equal to 12. 12 minus 7 will be equal to 5. So we'll again get our answer to be 5. So now our sub array will look something like this. This will be till, yeah, this will be our second sub array whose count will be equal to k, right? So we'll directly 9 minus 2, 4, 1 minus 7, right? This is our second subarray. Now again, we'll try to calculate the same thing. Its frequency is also 1, right? After this, 8 plus 2 will be equal to 10. Now, since 10 is already there in our hash, so its frequency will be equal to 2. Now, 10 minus 5 will be equal to 5, but 5 is not there in our hash map, right? So moving on to further, We'll increment our pointer to this. 10 plus 6 equals 16. 16. 16 minus 5 equal 11. 11 is not there in our hash map, so we'll directly say its frequency will be 1. Moving on to further, 16 minus 5 equal to 11. 11 is also not there in our hash map. 11 minus 5 will be equal to 6. 6 is not there in our hash map, so its frequency will also be 1. 11 plus 8 will be equal to 19. 19 minus 5. 19 minus 5 will be equal to 14. Right? So 14 is there in our hash map, right? So we'll directly add this into our answer. So our answer will now contain 3 total number of subarrays whose sum will be equal to the required k value, right? 19 frequency will also be 1. So now from this, you can directly see we can have this subarray whose sum will be equal to the k value. Like till there, let me just erase this thing. Right? From we found 14 over there, right? So this will can be considered as x, and we find out there this can be considered as x plus k. So from there till there, like till minus till 8, this will be our k. So our array now, our third array will be something like this: 1 minus 7 2 6 minus 5 and 8, right? So this is our third subarray, whose sum will be equal to k value, right? After this, we'll again increment our counter. 19 minus 3 will be equal to 19 minus 3 will be equal to 16. 16 minus 5 equal to 11, right? So again, we'll find another subarray whose sum will be equal to k equal to 5, right? 11, its frequency is 2 over there, because 16 is already there in our hash map. So we find out that we'll again have this array whose sum will be equal to the 5, 8 and minus 3, right? Now again we'll increment our pointer to minus 7. 16 minus 7 will be 9, right? Now it's 9 minus 5 will be equal to 4. 4 is not there in our hash map, so its frequency will be 1. So moving on to 6, 9 plus 6 equal to 15. 15 minus 5 is again 10. So since 10's frequency is already 2, and so we'll add its frequency to our answer. 3 plus 2 will be equal to 5. Why we are adding 2? Because now we can find total number of sub arrays to be 2. Like, let me just draw this thing for you, like, so that you guys have a better understanding, right? Um, just observe this pattern, right? First sub array will be from this, like, since we find out 2 first, like from this to this position, we have sum as 10, right? So from this point till this point, its sum will be equal to 10, right? And you can also watch it over there, like from 3 till minus 2, its sum is also 10 over there, right? And where you find out 10, again, 15 minus 5 will be equal to 10. So we find out 10 over there, right? So as you can see directly, its sum will also be equal to k equal to 5. And this array's sum will also be equal to k equal to 5, right? Sum, sum. So now you can like have these number of subarrays. Like that's why we add 2 over there, right? That's why we store frequency of each and every element, so that we can directly add the frequency into our answer instead of incrementing it by 1 and 1, right? So you can see over there, like we have total number of subarrays whose sum will be equal to 5. So our answer will look something like this, 5, right? So now the sub array will be this. Let me just do this with a different pen. Um, this until this, and we'll also have a sub array from this till this. I hope like this thing is clear to all of you guys why we are adding this to over there, right? So now let's again increment the pointer to this. 15 plus 2 equal to 17. 17 minus 5 will be equal to 12, right? 12 is over there in our hash map. Just yeah, 12 is over there. So we'll again have another array. So we'll directly add the frequency to 1. So its answer will be equal to 6. And 17 is not there, so its frequency will be 1. 17 plus 1, 18. 18 minus 5 equal to 13. So at the end of this, we'll also have this array which is minus 7 till 6, right? We'll also have this array, right? So actually we forgot to add 1 also over there, because like after this 4 plus 2 will be equal to 6 plus 1 equal to 7. So we'll have a total of 7 number of subarrays whose sum will be equal to the value k. First one is this one, 4 comma 1, and second one is this one, and the third one is 1 7, this one, right? And fourth one is 8 comma minus 3, and fifth one is 4 1 7, this array. This is fifth one, sorry. Now sixth one is this array 6 5 1, right? This is sixth one, and this will be a seventh array, right? So we have a total number of sub arrays equal to 7. So now let's try to code this thing up so that you guys have a better understanding, right? But previously we also need to check like why we are adding 0 over there. Let's say initially, let's take this example 3 2 7, right? This is our array, right? So initially when we are adding 0 and its frequency will be 1, let's say its sum will be 3. 3 minus k is 5 over there also. 3 minus 5 minus 2 is not there in our, its frequency will be 1. 3 plus 2 equal to 5. So this is our first sub array whose sum will be equal to the required k value, right? So we need to add a 0 over there, because initially this will be our x and this will be our x plus k. Here x value is equal to 0. I hope you all of you get like why we are adding 0 initially in our hash map, right? So now let's try to code this thing up. So here we are. Initially we'll have our answer equal to 0, unordered map. Now initially we'll have a 0, and like sum will be equal to 0, previous sum, right? Prefix sum, sorry, and sum equal to 0. Now we'll run a loop and num until nums. In this we'll try to calculate the sum. After this we'll check if this value, if the target minus some minus target is present in the hash map or not. Map dot count some minus k, right? Then we'll add the frequency of that particular element in our hash map, in our answer, sorry. So after this, if this is not the condition, then we'll directly increment the frequency, right? At the end of this, we'll return our answer, right? So now let's try to run this code. It runs perfectly fine. Now let's submit this code. Yeah, this code runs perfectly fine. Now let's discuss the time and space complexity for the same. So here we are. Since we are just iterating over the array, so it will require a big of n time complexity. And when you talk about the space complexity, since we are inserting all the elements in the hash map, so it will require big of n space, right? I hope this approach is clear to all of you guys. Like, thank you so much for viewing the video till the end. Please like, share, subscribe, and comment if you have any doubt. Thank you so much.